In recent times, changes to Earth have been quite significant, and these changes are the result of people. What are we doing, and how is it having an impact on Earth? These changes have been so great, it has led some geologists to propose a new geologic epoch, the Anthropocene, or the age of humans. From Greek, anthropos means human, and kainos in Greek means new. So this would be the new age of people. The human caused or the anthropogenic changes to Earth are argued to be very substantial. For example, if we go back around 12 to 15,000 years ago, this was the Neolithic Revolution. This is when agriculture took off. Cultures around the world began collecting animals and raising animals as a food source. We planted vegetables and fruits, and we bred them for their better qualities to grow them tastier and larger. This revolution led to large-scale deforestation of the earth, as well as damming up rivers, diverting rivers with canals to water fields. So quite a lot of changes happened then. But in more recent times, even larger changes have occurred. For example, from 1712 to 1850 was the Industrial Revolution. People around the world began building factories and machines in these factories to produce a lot of products. Now, early on, the energy source for these factories would be water. Flowing water in rivers would be dammed up, and a water wheel would spin the machines. But in later years, with the development of the fossil fuels, we began consuming fossil fuels. Initially coal, then natural gas, and petroleum. A lot of changes have occurred with that. Transportation of goods and materials, as well as the consumption of fossil fuels. By the mid-20th century, agriculture was so dominant that significant amounts of chemicals were being used. These chemicals were fertilizers so that plants could grow quicker and healthier and larger, and also pesticides, whether or not they are to kill off an insect or a fungus or mold, such that our plants, we could have a better yield on the plants being farmed. Also around this time is known as the Great Acceleration, where human activity generally increased. More driving, more traveling, more consumption of resources on the earth. And of course, nothing is as more important as the atomic age. And in 1945 were the first explosions of the atomic bombs. Worldwide changes that have occurred in recent time, including the loss of biodiversity. By biodiversity, I mean the number of different kinds of species across the world. Currently, we're losing species on the order of about 100 to 1,000 times faster than we should in normal times. This has led some people to argue that anthropogenic changes are causing Earth's sixth major mass extinction event. By loss, I mean that if a species goes extinct, we've lost that species, or if the species has died out significantly in an area, it's no longer going to be of any significance in that area. So between decreasing the amount of, say, coyotes in a woods, or a species like the dodo going completely extinct, that is a loss of biodiversity. Now, there are a variety of causes for the loss of biodiversity in recent times. Most notably, this includes habitat destruction. As we build out suburbs and use land for farms, we have destroyed habitats where certain plants and animals could live in. If we convert a suburban neighborhood that may have squirrels and bunnies and whatnot, and we build it up more intensely into an urban environment, they won't survive in that situation. So, building up larger and denser cities leads to biodiversity loss. Pollution of water and air leads to diversity loss as well. And most notably, climate change is leading to organisms unable to survive there. And of course, if we have an invasive species, that could completely wipe out a habitat. An invasive species would be a species that's foreign and not naturally found in a given area, but when it arrives there, it has no natural predators, and so it thrives to the detriment of other species. Been many other notable impacts as well from anthropogenic usage of Earth. For example, since the Industrial Revolution, with the consumption of fossil fuels, we are seeing temperatures warming across the Earth from an increase in carbon dioxide in the atmosphere. The carbon, which was stored on Earth for a long time as coal, natural gas, or oil, is now released into the atmosphere, causing Earth to warm. As we've built out cities and farms, and built more roads, deforestation and road construction and parking lots have led to an increase in sedimentation. We've also seen a change in trace elemental signatures across Earth. For example, mercury is found in coal, and the consumption of coal since 1850s have seen a rise in mercury found in glaciers. We don't see mercury at great depths in ice that's older than 170 years old, but more recent ice, we're seeing a large spike in mercury in that ice. Along highways, we're seeing an increase in vanadium and other heavy metals associated with brake pads. And of course, 1945, we had nuclear tests and the 2 nuclear bombs dropped in Japan. In those nuclear explosions, a new radioactive isotope formed, cesium-137. Cesium-137 has also come up from meltdowns like Chernobyl and Fukushima. But if we go back in the geologic record, there was no cesium-137 prior to 1945. Maybe these changes just are not significant, especially on a geologic scale. For example, while we are currently seeing a massive spike in carbon dioxide from emissions from transportation and other fossil fuel use, if we use more renewable resources, carbon dioxide will decrease, and the climate will cool back once we transition away from fossil fuels. This will take maybe 100 or so years once we have stopped using all fossil fuels. So the spike in carbon dioxide may simply be transient. In addition, the current loss of biodiversity we're seeing around the world, leading to the argued new mass extinction event, we don't have definitive proof of that. We are not yet at that mass extinction level. Remember, when we talk about mass extinction events, we're talking about 75+% of species going extinct. Certainly, species have gone extinct. Certainly, biodiversity is quite limited these days. But if we change our ways, if we conserve habitats, if we limit anthropogenic climate change, we can slow and even stop the current observed loss of biodiversity. So maybe it's just a small dip as well. And what about that cesium-137? That's a great marker for 1945. It's only found because of nuclear bombs and nuclear power plant meltdowns. However, cesium-137 is radioactive, and its half-life is only 30 years. And when that half-life occurs, the cesium-137 decays to barium-137. In fact, 11% of all barium on Earth is barium-37. So if we look in 300 years, we won't have significant amount of cesium-137 remaining. We won't have that distinct marker. And because we have significant amount of barium-137, it's going to be hard to find that radiogenic daughter in the sedimentary record. The International Union of Geological Sciences, or IUGS for short, is an international commission of geologists who work on refining the geologic timescale. In March of 24, this idea was brought up for a vote. The idea being that we should have a new geologic epoch, the Anthropocene. IUGS ended up voting 12-4 against adding the Anthropocene as a new epoch. And in their report, they raised some concerns. First off, and most importantly, is that there's no agreement amongst scientists on where should the start be. Is it 15,000 years ago? Is it 200 years ago? Is it 1950? There's no good agreement on the start. They also argued that we have perhaps a recency bias, meaning that we're seeing a lot of big changes to Earth, and we have great evidence of these changes. But over time, erosion occurs, and we may lose evidence of things. So just because we have a lot of evidence on something doesn't mean we will always have a significant amount of evidence on the idea. So perhaps we're just too familiar with these changes and they won't last. And perhaps most importantly is that there's no good long-lasting geologic marker. We don't have a large spike in uridium worldwide marking the Chicxulub impact for the Anthropocene. Cesium-137 would be the best of these potential markers, but it decays away. So the Anthropocene is no longer being considered as a new epoch. Instead, we will refer to the Anthropocene, or the Age of People, as a geologic event, meaning it spans time, it has great significant change to Earth, but it doesn't rise to the level of being significant enough to be its own time frame. And I will wrap up talking about the Anthropocene by quoting directly from the IUGS's report in March of 2024. Quote, "Despite its rejection as a formal unit of the geologic timescale, the Anthropocene will nevertheless continue to be used not only by earth and environmental scientists, but also by social scientists, politicians, economists, as well as the public at large. It will remain an invaluable descriptor of human impact on the Earth system." End quote. So while it's not a new time scale step, it will nevertheless be an important time in Earth's history.